Alright, hang on. Let me just make sure I get the engine mount struts in here correctly. Perfect. T-minus 7 minutes. Alright, we will switch to booter coverage. Booter coverage. And then we'll send this. Yeah, then we'll send this thing. And yeah, save that. Tab out here. Go over here like this. Go over here like this. Switches over to science and technology. I'm gonna put that in the title. So this should be about a 2-minute burn. This is a 5-segment prototype or 5-segment booster that's trying to test out the processes in manufacturing for these 5-segment boosters. This is one of the 2 boosters that's on the side of NASA's SLS rocket. So,
Roger.
Okay, let's see what we got. Who's Roger? Major component being tested for this one is the electronic thrust vector control and booster obsolescence life expectancy. So, composite casings? So, Vulcan, you're telling me this is a 5-segment Omega booster? Envy, what can you do? Steely's with the thrust vector.
5 minutes.
Okay, 5 minutes. You gonna give us a camera angle, NASA, or?
I'm Alyssa Lee, and you're joining us
T97
live.
Thank you.
Here at the Northrop Grumman facility in Promontory, Utah. Teams at NASA's Kennedy Space Center in Florida are preparing for the first Artemis launch. And we're here in Utah as
for
teams
Pete's
evaluating
sake.
materials and processes for future booster designs. We are moments away from a
All
hot-fire
high-speed
test
systems
of a
are
Space
streaming.
Launch System booster motor for those future Artemis missions to the moon.
NASA.
Today's test
Why?
is called Flight Support Booster 2. We did see a delay of this test today, but we are here and we are ready to fire up this booster.
One channel,
The
dude.
booster motors for NASA Space Launch
They're
System
streaming
are the
in frigging
largest,
mono.
most powerful ever
Who's
built
mixing
for
this
flight.
sound? Come on,
SLS
man.
has 2 solid rocket boosters that flank either side of the rocket. And for
Oh,
2
hey,
minutes
Reed.
today, we're going to see the power
Cool.
of just one of
This
these
guy's
here in the
cool.
Utah
Reed Wiseman,
desert.
Navy pilot.
If you're just now joining us,
Oh,
we're
former
about
Navy
5
pilot.
minutes
He's an
away
astronaut now.
from the Flight Support Booster 2 test in Utah. The booster motor used for today's test is locked to the test stand just behind me.
T-minus 4
Be sure to
minutes.
follow us
4
on
minutes.
social media at NASA
This is the
Space
test
Launch System
conductor.
on Facebook
Report system
and
status.
NASA SLS on Twitter.
Support
But no matter
systems.
where
I
you're
swear,
watching,
Chris, if they
you
mix
can
the
ask
audio
us
like
more
that, I'm
questions
gonna
by
kick
using
some
the
of them in the face.
Systems are go.
#AskNASA.
High-speed systems are
We're
go.
going to have some booster experts join me
are
here
go.
after the test to answer
Motor
those
temperatures
questions.
are go.
And now I'd like to introduce
We
you
are
to
go
a special
for
guest
That's
for
Reed
the
Wiseman.
today.
Static test.
This is Reed Wiseman, NASA astronaut,
What's up, buddy?
engineer, aviator, and chief of the astronaut office. It's an honor to have you here today, Reed. Thank you for joining us.
You bet. It's great to be here.
Yeah. So we did see a delay today.
Oh
Can
my
you
God,
explain
Chris.
more about what that was about?
So what we were told is they were having trouble communicating with a few of the cameras that are up at the test facility there by the booster, but they're going to proceed without that data because it was not critical for the test. So we're
There
back
must
to
be
the
some
test
reason why they're doing
about
this.
3 minutes away from lighting this thing.
Yeah, and we're excited to see it. I mean, it's going to be a great experience. I believe this is your first.
Is this your
booster
first test?
It is. It
All right,
is
so
mine.
both of us. This is
Yeah.
our first test. Yes, this is the first time I've been at one of these booster tests, and I just think it's absolutely awesome that we'll be launching Artemis 1 in just a few weeks on 2 of these boosters. So it's really neat to get to be here today.
Yeah, we're excited for launch. Now, can you tell me more about why testing like this is so important?
Because when we put humans on these things, we want to make sure they work. So they're testing a few critical systems on this booster today that's not related at all to Artemis 1, but is related to our future crewed Artemis flights.
Yeah, I think Artemis 3 and beyond is what we're testing for today. And so can you kind of tell me more about what we're expecting to see with this booster test?
About 2 minutes of a lot of heat and fire coming out the back of that motor. And I know about 4 seconds after it lights off, we should feel the pressure wave and hear the sound, much like we were watching a shuttle or an SLS launch at the Cape. I think it's going to be pretty awesome. I mean, the wind is coming down the hill kind of right at us, so it should be carrying
guys, I was telling Das, I'm straight up, I was telling Das this. I was like, dude, you got to see this.
Plus employees from Northrop Grumman out here to watch.
That's what I was just sending a message to. I'm like,
yeah, and I think the cameras might even shake a little bit from this test. I mean, you got to think about, we're only getting a little taste of what we could see at launch. You know, this is only a single booster, and at launch we're going to have 2 of those, so it's going to be a great sight to see.
2, and then the 4 RS-25s on the bottom of the core stage going off, you know, about 6 seconds before the boosters light off. So it's just going to be absolutely amazing to watch what American ingenuity, what the American workforce can put together when we launch Artemis 1 here in a couple weeks. I can't wait to be there to watch it.
I absolutely agree.
There must be a reason why. There must be a technical reason why they did this. Probably their setup out there could only support it doing like this. Nobody, guys. All right, I got to give NASA the benefit of the doubt here. I know their casts usually suck, but I got to give them the benefit of the doubt here. This would not pass any audio check. No way. There's no freaking way. There's a reason why it's doing this. They probably just don't have the hardware out in the middle of Utah out there to get it to mix correctly. That has to be the reason. Nobody would put their name on this production and have it do that willingly. I guarantee that.
Systems are recording.
All right, here we go.
T-minus 50 seconds.
I'm going to go over here because the booster's over there.
TVC is go for static test. T-minus 40 seconds.
And of course, they switch to a shot where I'm right in front of the booster. Okay.
T-minus 30 seconds.
Okay, there we go. All right, so you see that area right there? Like right in this area right here? It's about to get extremely hot. Like right in this area. You see that bullseye? NASA's aiming for that bullseye. Yeah.
T-minus 10.
Watch.
9,
Watch the birdie. Just smile and wait for the flash.
6, 5, 4, 3, 2, 1, fire.
Power! Ah, that's hot. Oxen!
30 seconds.
It's a lot of power. 14,000 kilonewtons of thrust, guys. Basically, this booster is pushing with a force equivalent to about 2.5 million pounds. The force that a 2.5 million pound block of concrete would push down on the ground with. I think it's 2.5. I'm pretty sure. So how much did we just push the Earth? Yeah, a little bit. Look. The sand on the side of the hill is turning to glass because the booster is so freaking hot. Look at how much heat is coming off this thing.
Open the accumulator enable valve.
Accumulator is enabled.
Full duration, Panther, yep.
Activate half deluge.
Activated.
Activate forward deluge.
Alleviate. You could hold the s'more up 100 feet away, and the s'more would cook itself. That's how much heat's coming off of this one. There's a tail off. Stand by for the tail off and flame out. Okay, we have tail off, and there
Activate head and CO2.
is a flame out there. We've got some residual.
Activate quench tool forward command. Activates aft CO2.
Okay, so now they're going to extinguish the booster. If the booster was flying right now, you'd get some residual fire from just excess from other propellants burning off. But now what they're going to do is they're gonna that the little dingle arm's gonna go into the booster and it's shooting out CO2 to inert the booster and put out the fire. Basically a big fire extinguisher. Yeah, note that sign that was over there is not existent anymore. So, just in case you were wondering, they had a sign here, and it actually wasn't a sign, it's a mirror. The reason why they have a mirror is because it's for engineering footage. They want to be able to look up the business end of the booster right at ignition, but they can't because you can't put a camera here because usually anything that's behind the booster you're going to lose, like the side of that hill right there. It just cut a hole right in the hill because that's what it does. So what they do is they have a camera that's pointing at a mirror so they can see right before ignition happens, they can look up the business end of the booster. That's what that sign was. There was a bunch of instrumentation back there to show it. To show the, like there was a bunch of locator marks and then there was the mirror. And they have a camera like over here or something. Like I think that might be it right there, I'm guessing. That's looking at that mirror. That's why that thing was back there. And that thing is no longer here because, yeah, the booster vaporized it. It's raining soot. Oh, I see it. Fire extinguisher, Flacken. That's what that is. Will this booster be reused? The casings are reusable. Sure, absolutely. Uh-oh. Hey, hello?
Welcome back. And wow, what an amazing sight to see. This powerful solid rocket booster fired up. Again, we're here at the Northrop Grumman facility in Promontory, Utah, where we just witnessed a 2-minute booster firing of a solid rocket booster for the SLS rocket. Here with me to talk about that test and to answer your questions, we have Julia Cotabande, motor team lead for SLS boosters at NASA's Marshall Space Flight Center, and we have Jessica Rose, chemical engineer for Northrop Grumman for the SLS boosters as well. So before we begin,
yeah,
I just
the
wanted
microphone
to
is
say,
through the right
we heard
channel.
the test conductor talking a little bit before.
That's the stream, guys. I can't do nothing about that.
The firing. Can you explain a little bit more about what they were saying? So I'll start with Julia.
Yeah, thanks, Alyssa. Wow, that was fantastic. So yeah, we heard the test conductor before the firing of the motor. She gave the go for test. The test counted down. They committed the motor. They armed the motor. And then at T0, we saw smoke and fire. We have out there today 5 segments of solid rocket motor. At the T0 mark, a signal was given from a ground controller to an igniter assembly, which in turn ignited the 5 segments. At the other end of the motor, we have a nozzle assembly, which had a nozzle plug, and that would have come out as pressure built up inside the motor. We also have an aft skirt assembly, and it houses our advanced booster electronic thrust vector control system, and that vectored the nozzle during the test.
Yep.
A little bit later, you heard the test conductor call for the water deluge,
okay.
which actually sprays water on the belly of the motor in order to cool the case.
You could go towards
And
it
we
right
do
now,
that because
Alleviate.
we want
It's
to
fine.
preserve and protect.
They're going to have
our
teams drive
hardware.
out there in a moment.
And then a little bit later, we had the forward CO2 cooling and an aft boom swing around and send CO2 cooling into the aft end of the motor. So yeah, the motor burned for 126 seconds, which is how long it will power the Artemis rockets during liftoff and early flight. And it was a great test.
Well, thank you for that great detail, Julia. So, Jessica, how did you feel? And can you tell us a little bit more about how we got to this moment?
Yes, absolutely. So, first of all, absolutely amazing. That is
Guys,
so
I might be able to
bright.
mix this
I
right.
was
Hold on.
wondering if I'd be able to see after it, and I've seen many of these. It's so impressive every single time. And that's what all these employees out here that work at Northrop Grumman and NASA that are here that work on the Artemis segment are so thrilled for to see that what we do daily impacts that success that we saw. And Alyssa, to answer your second question, here in Utah, we manufacture these boosters from the beginning to the end of them. We start with case prep. During case prep, they prep the case and then they'll insulate the case and then line it. Once the case is lined, they'll then go down to the casting pits, where they invert this horizontal segment into a vertical position.
Is it
all the
good,
way
guys?
down into this deep pit that fully covers the motor. And then after that, they start prepping it for what they call as a cast campaign. During the cast camp, they will lower the propellant into the motor at a continuous rate. Once the motor is full with propellant. It'll cure for about 1 week. After that week, they'll commission and send it on down to X-ray. During X-ray, they will see if there are any voids in the propellant. If not, they will go down to the final assembly building where they finalize these motors. They will put a igniter in the forward segment and a nozzle into the offset. They will then either send them here.
I'm trying to balance it as best I can, guys. It's only so much I can do.
Addition storage building for when Kennedy Space Center requests some Artemis segments. So it's quite pride-filled that we get to take from the beginning to the end of these boosters.
Yeah, it sounds like a lot of work for both NASA and Northrop Grumman has gone into this 2-minute booster firing. That's awesome. So now we're going to get into some viewer questions. It looks like our first question is for Julia, asking how big.
Why
are
did
the
he?
SLS boosters?
They have it on automatic exposure.
So the SLS boosters are 177 feet tall. So that's going to be equivalent of a 17-story building. It's also
Bro.
as tall as the Statue of Liberty
Bro.
is from her base
Bro.
to her torch. Now the motor that we had out here today in our test
Bro.
stand wasn't quite that tall. It was 154 feet. And the reason is because we don't have the forward assembly that we have on our flight boosters in the test stand. The forward assembly consists of a nose cone, a frustum, and a forward skirt that houses our flight avionics. However, in the static test, we actually use avionics that are part of our test stand.
I mean, that was impressive to see, and you don't realize how big these boosters are until you're actually standing there in front of them. I actually got the opportunity to see the Artemis. One rollout.
Oh, there we go.
Seeing how big it is. Jessica,
Oh.
why do we test in Utah?
Okay, perfect. So like I talked about, we do manufacture these here.
The other mic is open, Miles. Yeah.
1,000 pounds each. And we have a test stand that can stand these. The test stand has 13 million pounds of concrete in it, most of that underground. And so from that, there's 3.6 million pounds of thrust that comes from the 1.6 million pounds of propellant.
All right.
Propellant that
I'll answer questions, fellas. That I can't deal with that audio. It is just killing me. It's just killing, dude. I can't do it. All right. So what's the internal structure of the booster look like? I know it's mainly filled with propellant, but how can it withstand those compression forces? Well, the boosters are made out of steel. Unstoppable. It's a steel casing. It's a steel casing, and then on the end of each segment, there's basically a flange, and then they bolt them together. And then the O-rings are in between each casing. Yes, those O-rings. There's 3 of them. That design has basically been the same. It's a steel casing for now. They might switch to carbon composite in the future. It's possible. But yeah, basically the booster's made out of steel. You couldn't make that thing out of aluminum. It wouldn't be able to withstand the pressure. It has to be steel, and it has to hold up the stack too. That's also important. So long story short, the boosters are thick. They're thick steel. They're really, really freaking heavy. But they also carry propellant that's very energetic, to say the least. Yeah, as you just saw. So, like, you're releasing a lot of energy, and you do have a heavier booster than, like, a liquid fuel tank, but it yeets. That's what the kids are saying. It yeets. Nobody says that way. There's no estimated launch date, Def. There is an official launch date on the 29th at 8 a.m. That's when the launch window opens. Rollout is on the 18th of August. The 29th of August. So we're about a month out from Artemis. So, yeah, how that works, guys, is basically just it's a steel casing. It's just a steel casing, and it's a hollow steel tube. That's what it is. It doesn't get any simpler than that. It's just a hollow tube. And there are segments that are joined together right here. The segment joins are in between the stripes. So there's one right there. And they basically just bolt the segments together. There's a lot of bolts all the way around because they really need it to clamp. But yeah, that's it's just a steel tube. That's all it is. That is just an Estes rocket motor that's 170 feet tall with an electric thrust vector controller. Older shuttle SRBs used a hydraulic system to turn the nozzle. And the nozzle actually pivots on the throat. It has a movable nozzle because if you tried to gimbal this whole thing, you'd need to gimbal at the top and the whole booster would need to move. So they went with a nozzle that moves back and forth. How did they do that? The nozzle overlaps the throat a little bit. Kind of like this. So if you have your aft casing on the SRB right here, and if you notice, the aft casing has structural rings that go around it like this. Those are, well, you asked for how it stays together. Those rings keep that thing clamped together. And then you have the back of the booster that goes down like this, and then you have your throat, and the aft segment on the booster basically looks like that, right? It looks like a CO2 canister almost. And then at the bottom of the booster, you have your aft skirt, which looks like this, right? And the aft skirt is what houses your thrust vector controllers, so it's a piston here and a piston here. If we were looking at the booster up the business end, you have 12, 3, 6, and 9, right? The thrust vector controllers are at the 12 o'clock position and the 3 o'clock position. That allows the nozzle to be able to move left, right, and up and down. Now, the nozzle is on basically the biggest Heim joint you've ever seen. The nozzle actually kind of goes over the throat. I didn't draw the throat right, to be honest. The throat goes out here like that. And then the nozzle is out here like this. And the nozzle actually pivots on the throat. It's kind of like a Heim joint almost. And those thrust vector controllers are attached to the nozzle, and the nozzle can move. They were using electronic thrust vector controllers. During the shuttle, the controllers were a hydraulic system. The electronic ones just have a couple of batteries down here, and then you're good to go. The reason why they're switching to an electronic TVC is, one, it's simpler, less parts. Two, the booster's getting expended. It doesn't matter. And then, if you really want to know, the hold down points for SLS are actually on the booster aft skirt. The hold down points are at the, they're basically at the 2 o'clock position here. They're at the 4 o'clock position there. And then they're at the 8 o'clock position here. And the 10 o'clock position there. And what the hold down points look like is basically a flat part of the aft segment that just has a hole in it. Just a big drilled hole. The big drilled hole is there to hold the explosive bolt. So basically, when SLS in this booster leaves the pad, right? When it leaves the pad, these explosive bolts pop and then they slide out and the SRB separates. Pretty straightforward stuff. Is there a video out there looking at the business end while starting? Yeah, Unstoppable. Yeah, there is. Would you like to see it? Yep. All right, cool. Let me shut out of that diagram here. SRB test NASA. And NASA stopped the stream. There is a shot looking through that mirror. It is around on YouTube. I gotta find it. Give me one moment. Chat's probably gonna find it faster than me, but S24 is testing right now. We will check that out in a second. I'm trying to find... Wobble, you got it? Oh, no, never mind. Sup, not watching the Ship 24 test. Sup, I'm finishing something else real quick. A lot of space stuff, buddy. Here we go. Here we go. Alright, let's just make sure that that stupid noise is not on there. So here, take a look. This is looking up the business end of the booster. So inside of that throat that I was talking about, the nozzle is out over here, and the nozzle is an ablator nozzle. So the nozzle is basically made out of heat shield. And when the explosive SRB, or when the hot SRB gases that are coming out of the booster hit the nozzle burns off. and it basically it film cools the nozzle on the SRB. It keeps it nice and cool. Same idea as supersonic retropropulsion, or an ablative heat shield on a capsule coming back. So, inside of the throat there, you have the booster plug. That's the booster plug. You don't want a bird flying in here and, making a nest inside of the SRB. One, obviously, ethical treatment of animals. Second part about that is that that will make the booster do something that, you didn't want it to do, most likely, because when you did your testing, you didn't take into account a bird nest being in the combustion chamber. Pretty straightforward stuff. The booster plug is just made out of foam. It's just polyurethane foam, if I'm remembering correctly. I've read a lot about it. It's off the top of my head. Watch what happens when the booster goes off. Boop! Yeah, yes, it does blow a ring because of the overpressure event. There's the mirror. That's how we got that booster plug shot. And that mirror is about to not exist. See ya. But if you look at that camera angle, you look at it just for a second, see? You can see the booster plug. See it? It's right in the mirror. And that's what that first shot is. It's looking at the mirror. And now, when they ignite the booster, it's a spark igniter, as the NASA people were saying. But actually, it's not a spark igniter. It's more of a torch igniter. They have a little, like, Estes rocket motor up in the front segment of the booster. And they fire the rocket motor in there. The flames from that little tiny igniter motor ignite the grain, which is the industry term for solid rocket propellants. It ignites the grain, and it starts at the top, and the flames work their way down. Now, the grain is just packed around the edges of the booster. It's packed on the outside. So if you remove the booster plug and you shined a flashlight up there, you'd be able to see all the way to the front of the booster. But the cavity the booster grain is packed all on the outside, and there's maybe like 1 foot or about 30 centimeter inner hole that goes all the way to the front. And the grain is packed up against the walls of the booster. So when they fire it, that little tunnel, I guess, in the grain that goes all the way to the back, that's what you're seeing right here. You're seeing the fire go down that tunnel, and the overpressure event blow the booster plug out. Now, if you're wondering what the propellants are for this SRB, it's hydroxyl terminated polybutadiene, so HTPB for short, which is just some chemical that, almost like epoxy, I guess. And then they use ammonium perchlorate with aluminum flake stabilizer. This thing burns metal. Yeah, it partially burns metal. Metal actually helps stabilize the grain, and it stabilizes the explosion, so you get nice uniform combustion. Yeah, aluminum is part of the propellant. Aluminum burns really, really good, actually, fellas. It's a really good fuel. Go figure. And it is solid. Yeah, it's a really good fuel. You ever notice, if a plane lands or something and it skids out, and everybody gets off the plane, and then the plane catches on fire. When it catches on fire, there's no plane left because aluminum burns really, really well. It's flammable. In the right conditions, that metal is flammable and will work like fuel. And this is a really good case of it. And just like magnesium, when aluminum does eventually end up burning, it releases an insane amount of energy. It's really good fuel. Not very efficient burning metal, but it does release a lot of energy. Which is exactly why you don't want aluminum LOX lines. Yeah, there you go. So that's what we just saw right there. But this is footage from a different booster. You guys wanted to see the plug. Yeah, there you go. Little word on the SRB. You can see the hold down points for the pad right there. They're not using them because this booster, is pushed. Actually, they have the booster pushing up against a load simulator. It's a load cell, if you really want to know. The load cell is right here. So they have a load cell, right? And that load cell is on a spring. I think it's spring loaded. And the booster is going to push, and the booster will actually push on this load cell, and it pushes on the spring. And how much it compresses that spring from the compression forces that's introduced by the booster on that spring, they can deduce how much thrust it has. Now, don't get me wrong, there's probably a sensor on there that'll just going into a computer that'll just tell you, but yeah, That's how they measure the thrust of the booster to make sure it performed right, with this load cell piece right here. When the booster turns on, it jolts forward just a tiny bit. It's not enough to see, right? It's obviously not enough to see. They don't want that thing sliding around, but it's enough to push. It's enough to push on the spring up here. Last boss, a better view of the plug being ripped to bits. Okay. Yep. Okay. Nice. What if they attach landing gear to the spring? Well, then you're going to have a crazy amount of energy. Yeah, so much heat is coming off of this thing. If you look, and we could see this on the test that we just saw, but it's burning sand around the booster. It is burning up the sand and turning it to glass, like over here and stuff. There's a reason why nothing is over here, except for the cameras right here, and those are behind a metal wall, or a concrete wall. Look at that. Watch. And I don't know if we could see it from that test, but they are turning the nozzle. They're doing... just up, down, left, right, A, B, start. Yeah, the booster produces about 14,000 kilonewtons of thrust, which... actually, now that I said it was about 2.5 during the test... I said it was about 2.5 million pounds of thrust. No, it's closer to 3 million pounds of thrust. So that booster pushes up with the same amount of force of a 3 million pound block of concrete pushing down. So like if you had a 3 million pound block of concrete, you had a car underneath it, the force and then you let the block go and it crushed the car, the force that crushed that car is how much upward force that SRB has. It's a lot of power, man. There's a lot of energy being consumed there very quickly. But that's rockets. Pretty cool, huh? Yeah, Chief. Yeah, PepCon. Yeah. Supply chain issues. Oh no, because the shuttle stopped flying. True story. 4K drone B-roll footage from a 2020 test. Well, guys, we got to go over to S24 because the more time I spend not showing S24 on the screen, yeah, the more people are going to be like, "What are you doing? You're not covering S24." So we're going to move over to SpaceX Ship 24 testing. Barely, potato, barely. All right, here, let's see. This 4K footage here, let's take a look. This is from September 2nd, 2020, but it's the same idea. Yeah, there's the booster. There's the load cell up there, like I was telling you. There's the load cell. There's those hold down points. If you're wondering what those things are on the side of the aft booster skirt, that's a separator motor. That's the SEP motors. They're probably inert. You don't really need them for this test because you're not separating from anything. In fact, you don't want this to separate from nothing during this test because that would be unfortunate. How unfortunate. Yep. And see that big block of concrete? That's what the load cell attaches to, because they don't want this thing to move much. You want it to push on the load cell, but that's about it. There's also some pneumatic systems over there. That's most likely the CO2 for the booster inerting device, which is what that thing is. This footage is...
seconds.
Oh, this footage is sweet.
T-minus 45.
It's the third stage, Ozzy. The second stage could have put the third stage completely on orbit, but they didn't want space junk. So the second stage shut down right before orbital insertion, and the S4B did 2 burns. One was the LEO insertion burn, and the second one was the TLI burn. Yep.
It's 40 seconds. That flush opening.
Yep, there's our ablator nozzle. There's the booster plug. There's your hold downs, separator motor.
T-minus 30 seconds.
Oh yeah, soapbox, absolutely. Yep, there's the load cell right there.
Minus 15. T minus 10, 9, 8.
There's no brush to light on fire. You can clearly see that the booster is dug down to bedrock just from the thrust from past tests. You see there's bedrock right there. It literally scraped the topsoil completely off.
5, 4, 3, 2, 1.
Yeet!
Fire.
Okay. That's pretty neat. Look. The heat coming off from the booster is melting the sand. Melting the sand. That's how much heat is being radiated here. Look at all of it. It's melting stuff. It is ablating the soil and it's ablating concrete, even from like 30, 40 feet away. Is that crazy or what? Good, I hate sand. Not dust. Some of it is dust that's getting kicked up, Miles, but this dust that's getting kicked up over here, some of it got kicked up from the initial overpressure event, so when the booster turned on, but look, it's still coming up there. It's melting stuff that's 100 feet away. That's how much heat is getting put out of the bottom of this thing. And the worst part is that it's unstoppable once lit. Not true. This particular design of booster, Mike, is, yeah, you don't really want to be able to shut it off, because if it shuts off, you're, yeah, gonna have a bad day with whatever launch vehicle it's attached to, especially if there's two of them. You'll get thermal curtain failure. Not a good idea. Anyway, but a lot of people think that you can't shut off SRBs. You can shut off SRBs. But if you're going to shut off SRBs, the SRB itself needs to carry around a bunch of inert gas that can get pumped in if you want to shut the booster off. You can inert the SRB even when there's fuel in it. You gotta spray you gotta spray inert gas through the combustion chamber. That's what they do when the booster tails off. That's what this thing does. You can shut it off if you really wanted to. But the reason why they don't is because the weight, the extra mass of moving all that stuff up in space is useless. Why would you do that? It's just extra mass, and honestly, you don't really want to shut the booster off. SRBs are ridiculously simple. There's two moving parts. Well, three technically. The nozzle moves, and then the two actuators to move the nozzle. That's it. Three moving parts. Now, don't get me wrong, there's a lot of parts on the SRB. It's complicated, but it's about as simple as you can get for this amount of power. You want to generate this type of power with liquid fuel engines. It's not good. That's going to be really hard to do. The reason why that would be really hard to do is because, so the Saturn V first stage engines, the F1s, they produce, one F1 produces half the amount of thrust of that. And the F1 is barely on the ragged edge of working. They had trouble with the F1 engines on the Saturn V maintaining combustion chamber because they used the cylindric combustion chamber with it because there's no other way to flow that gas out that fast. It would have blown up otherwise. So because the SLS, or not SLS, because the F1 engines used the cylindric combustion chamber with a slight throat, and they had trouble sustaining combustion chamber, and that led to pogo oscillations. Read about Apollo 4 and Apollo 6 if you want to know more about that. But even then, an F1 engine is producing half of the thrust of that booster. Half. SRBs are really, really inefficient, but they're very, very energetic. They're great first stages. Would the explosive bolt be considered a moving part? Considering it's a hold down point, Chris, I would I would call the explosive bolt GSE. Or make such a bad propellant that it shuts itself off. Saw that happen in a test. Yeah, well, if you don't mix the propellant in the right proportions, Cyborg, yeah, it'll turn into a flamethrower real quick because you get combustion instability. Anyway, let's move over to S24 testing, and let's go from there. Or let me see what's going on with Ship 24 first. Hey, nice t-shirt. Yeah, thanks. I have one like this in real life. Anyway, let's see what's going on with Starship here. I'll switch us up to Spacex Ship 24 testing. I don't think that they're going to do a pre-burner test per se. Any hardcore Starship watchers in there? Did we get an overpressure notice at all? If we didn't get an overpressure notice, there most likely is not going to be any combustion. But we'll see. You didn't, Blue. Okay. Any info on when the launch is going to happen? Oliventi, August, I would say. The Booster 7 popping was a little bit of a setback. Do they need to notify overpressure for pre-burner tests? That's my understanding, LJ. Oh, vent down. Well, that's the end of that. Whatever they were testing, they stopped it. What was that? The pop. Booster 7 had they were doing a spin start test, and they were doing spin starts with live propellants and shot live propellants all over the pad, and they found a source of ignition and it blew up underneath the booster. They got to inspect the booster for damage. What we're seeing from Ship 24 there is a total vent down. They're bringing the tanks down from flight pressure. And you can see that the methane tank vents are on and the oxidizer tank vents are also on. Whatever they were doing, that's the end of that test. Oh, they're also testing 7.1. Jeez. That's a lot of venting in comparison to the early Starships. Yeah. Yeah, there's probably a good reason for it, Squidman, but I don't know what that reason is. If you note the pipes that are in the top left corner, below where it says 336, those are the umbilicals. If you see that the pipes are metal. It's metal flex tube, but they're all shiny white because that indicates that propellants are in the lines that go to the vehicle. See how everything is all icy? Where's the mouse? Right there. See? It's all icy. So do they just vent the LOX and recycle the methane? They have to vent some methane to bring the tank down from flight pressure, Sirius, but yeah, the methane is scavenged through a recondenser. They take the gaseous methane and then they have an electric recondenser that takes it and cools it down and turns it back into liquid and puts it back into the tanks. It's a scavenge system. NSF wrote that they already did 2 roll tests. Roll tests? Oh. 2 spin start tests at 309 and 331. Interesting. If they vent both LOX and methane, won't that make a very combustible gas outside a Starship? Nah, it's not atomized, Dane Boy. I mean, technically, yeah, but it's not atomized. You're venting gas. It will if they vent down like that if there was a source of ignition here, but there isn't any source of ignition there. So yeah, it's not a problem. It could, but yeah, SpaceX, I'd like to think that SpaceX is smarter than that to know that if you vent both of these next to each other, it'll pop. Now, granted, that is pretty much exactly what happened with Booster 7, but I don't think SpaceX, I think the reason those propellants combusted on Booster 7, they combusted underneath the booster. The reason I think they did that is because of some equipment that was left down there. I'm pretty damn sure that wasn't the booster. I heard that there's no visible RCS thruster holes on Starship somewhere. I heard it on a Starship documentation website, so take that with a grain of salt. There's no visible RCS holes? The vents. Aren't the vents the hole? Aren't the vents the RCS? If I'm remembering right? Or maybe that's just for the booster. There's probably a header tank vent up there, Reagan, that they're using for RCS. That was Elon's idea. How will Starship rotate in space? Rotate. You can rotate in 3 different axes. Olifanti, you got to be more specific than that. Are we talking about pitch? Are we talking about yaw? Or are we talking about roll? Will it have reaction wheels? Doubt it. I don't think so. I mean, maybe the human-rated one will. Mr. Yorkshire is back in here. Let's see what he has to say.
So far, with basically nothing happening in the space world, right?
Talking to.
Yeah, no, nothing going on. We've been doing absolutely nothing all day. It's been a super quiet day. None of us have any work to do. Nothing like that.
Perfect.
But you've been keeping track with the. We've actually been watching for a little bit. Of course, Adrian is one of the writers here at NASA Spaceflight, and the person who specializes in keeping track of all these Starship countdowns. And you've been keeping a close eye on the countdowns for all this Ship 24 testing and giving us some insight in our back channels here before you joined commentary of how far away we may be. So, any interesting observations from these couple countdowns that SpaceX has done today?
You could do that, Caveman, if you
Yeah,
really wanted to.
thanks for SpaceX for doing so much while I was trying to play Dungeons & Dragons. Yeah, I watched the test, and also we see the flare, the vent stack going on now. So that's my first observation. Yeah.
What a
they
nerd.
are detanking.
I mean that in an endearing way.
Yeah, I think this countdown up until the first spin prime test was, well, pretty standard. I'm quite happy with how it was all predicted, and yeah, it looked.
It's a little ways away,
normal
serious.
to me, and this looked
EJ
like
probably
a standard
loves D&D.
Countdown for.
No, I'm not really that big of a D&D fan, Mike, to be 100% honest with you. I'm a Warhammer 40k fan. D&D doesn't do anything for me. Warhammer 40k is where it's at. Blood for the Blood God. Skulls for the Skull Throne.
But we don't know what's next. This window is still going on for 6 hours and 19 minutes. So lots of room for more activity.
Yeah, we're going to stick around as long as the road is closed, and because that means testing is still underway. Although B7.1 is also being tested too. So as long as there's something interesting to show, like Ship 24 still being prop loaded,
milk
we're
for
not
the
going to go anywhere
cornflakes.
quite yet. But let's see, Adrian, I've got this question. This actually came in a little bit earlier in the stream, but I knew you were joining us in a bit, and I wanted to ask it while you were here, because I know, well, I think I know your answer. Maybe I don't. The question is, what rocket do we think will be the first Methalox rocket to orbit? So I'm going to preface this question while you two think about your answers. Using liquid methane and liquid oxygen as your liquid propellants for a rocket, while not a new idea, is becoming a thing for many next-generation rockets, based on its ability.
I played Cadians back in the day, Vickers, at my parents' house, and I'll get it when we move. I spent a lot of money. I made a lot of pizzas in high school to afford this, because my parents weren't going to pay for it. They thought it was overpriced, and yeah, they were probably right. I have let's see. I think it's a 2,000-point Cadian army. Yeah. Half painted. Should probably do that. Maybe we'll do it on stream one day. I liked Guard, Vickers. Yeah, the Guard was fun. I also have a 2,000-point Space Marine custom chapter. Custom codex. But it was a custom codex chapter because I didn't really understand the rules when I played 40k when I was younger. I didn't understand all the rules. Once I started figuring out how the rules worked, I didn't really like Space Marines. Space Marines are cool, don't get me wrong, but I like Guardsmen better. Nids, Wolfie. Ugh. Heretic. Popular kids don't play Warhammer 40k, goalie, so thanks for the shocking revelations. Nids suck. Stupid bugs. Stupid wannabe arachnids from Clandathu. Yeah, you can use your Nid army. And how about you meet my Basilisk cannon? Yeah, There, you'll just meet the Basilisk cannon, and yeah, we'll see. We'll see how much that Carnifex is going to survive from that. I have, in my army, Vic, I have 3 Lehman Russes and a Basilisk. And, dude, I cut down people with that thing. I remember I played a Chaos Army one time. Guy tried to charge me with Chaos Terminators, and I was rolling really, really well that day. Dude, laser pointers cut down Chaos Terminators. It was hilarious. That guy was mad. He was mad because he should have won. Did you see this? What is this? Criminal Enterprise coming to GTA Online. Oh, no, I haven't seen it yet. We'll check that later. Yeah. Dude, he tried to charge. Actually, no, it wasn't Terminators. I mean, this match was like 15 years ago, okay, so bear with me. It wasn't Terminators. He charged me with Chaos Marines, and I laser pointed them to death. He got within range of 3 squadrons of 20 guardsmen, and yeah, probability favored me. He put them in a really weird position, and then he tried to warp his Terminators in behind my lines to get my Basilisk, and they ended up warping into the Basilisk and dying instantly, and then he surrendered after that. Yeah, true story. I would move 1 squad of 20 forward, not maximum movement range, just 2 inches, and then the other squad forward 2 inches, and then the other squad forward 2 inches. Just take little baby steps. Anything that got within 20 inches of that, if you tried to come in anywhere on the center, right, I would have to roll like 60 d6, and you would die. Yeah. And then the Lehman Russes were behind that. I always put the guardsmen out front with the Lehman Russ behind. Have you seen this already? Can you guys do me a favor when you say, have you seen this? Can you just tell me what this is? Just do me a solid. Boom Supersonic. Yeah, we covered that for Space News the other day, Chris. Yeah, pretty cool, huh? Just tell me what this is. It's that. Oh, okay. Now we're good. Just in, we've selected Draper of Cambridge, Massachusetts. Nice. To deliver 3 NASA science investigations by 2025 under the Commercial Lunar Payload Services Initiative to the Schrodinger Basin, a lunar impact crater on the moon's far side. Oh dear. Yeah, they have 7.1 and 24 testing all at once, interestingly enough. Nice, Ordon. That's cool. So yeah, that's what I did with Guard. I would always just keep my squadrons of 20 Cadians with a command squadron behind him, and then Lehman Russ behind that, and then a Basilisk behind that. There were times where I'll admit I did play NIDS one time, and one time I wasn't rolling right, and I got annihilated. Yeah, like broke right through the lines, blew up a Lehman Russ in one turn, and that was the end of that. My line collapsed. But I did shoot the Basilisk at the Carnifex and kill it, which was pretty funny. Oh, nice, Moguni. Dude, is that air conditioner even on? It's so freaking hot in here. Maybe I'll just leave that like that, so blow the cold air this way. Try to get my convection system going. Is the old tank farm still there, or is this the new one? Ship 24 is connected to the old tank farm. You can see it in this frame right over there. See the smoke coming out? Yeah. I don't know what 7.1 is connected into. Yeah, yeah, I just wasn't rolling good that game. I remember that game pretty well. I just wasn't rolling good. I was rolling all ones. Like, I would roll like 20 d6 and get 1s, 2s, and 3s. And the guardsman got cut down. But I still have the army, yeah. I still have the army. It's in a foam 40k case. Yeah. I really wish I'd spent all that money on cars. Probably should have spent it on cars. That probably would have been a better use of my time, but it's alright. 40k is still cool. Still fun. Yeah, so, you know, D&D is pretty nerdy. 40k is really nerdy. So I woke up this morning with no sense of smell. Join the freaking club, dude. Yeah, there you go, Falcon. Yep. Yeah, Squid. Yeah. Battletech is another level. Yeah. Yeah, I guess. Yeah, maybe, Denny. That's possible. You do know there's a D&D version of 40K, right? Okay. Night Viper, you're saying, oh, you know that, you play Kerbal on PC, but have you know that you can play Kerbal on the console too, right? Like, yeah, I know. I don't know why you would do that, but all right. I played the original Dawn of War TARS, but yeah, after that, yeah. Last school term, I did an after-school activity where, with people from Rocket Lab, we built model rockets. At the end, my friend and I got awards along with 5 other people for doing well, and we get a private tour of the Rocket Lab production headquarters in Auckland in the coming weeks. Pfft, look at you. That's pretty sweet. Say hi to Peter Bick for me. Tell him there's some random guy that streams on Twitch that thinks he is the man. Yeah, pretty much, Jim. Yeah. It's called Dark Heresy. Once again, D&D... Why would you play 40K? Why would you play D&D 40K? That makes no sense. That, like I said, man, that's just dumbing. That's just watering down 40K. That would be like, that's like playing Kerbal on a console. Like, you only do it if you absolutely have to. But yeah, your boy was a big nerd back in the day. I mean, still, but I've just trained to hide my nerdiness. Stealth hide the nerdiness, you know what I mean? Under the guise of extroversion. Yeah. That's how that works. You need to train harder? Yeah. You do not do a good job at that. Yeah, you haven't seen me walking around in